Good morning, good afternoon, good evening, guys. So today we are going to discuss a very important topic based on laws of motion, and so this is going to be a very important topic. And by watching today's video, it might benefit you for many competitive exams in the future. So we are going to discuss about laws of Newton or Newton's law. It is also known as law of motion. So let's begin with the first law. For your note, there are three laws of motion. If you have any doubt at the end of the video, you can put your doubt in the comment box. Also, if you demand for any video, you can put the topic of the video in the comment, and I will try my best to make a video upon it. Let's start with Newton's first law. We are going to see the definition of Newton's first law. What Newton's first law states that now, before going to Newton's first law, there are two states of any object in the world: state of rest, state of uniform motion. This is related to Newton's first law. Now, in this definition, there is a highlighted word called net external force. What net external force means is that a force which creates acceleration on any body. Now, many people might have a question that what is an example of a force which cannot be called as net external force. So the answer to this question is quite simple. It is a balanced force. Balanced force is when the force acting on a body is equal in opposite direction. It still remains at rest. Now let us come to the topic and understand Newton's first law. It states that a body remains at state of rest or uniform motion until and unless a net external force acts on it. Take any object in the world. What is state of rest? I will explain you. What is state of uniform motion? I will explain you through two examples. Take example of two objects. One is in the state of rest and another is in the state of uniform motion. I explained you net external force. So if this net external force doesn't act on these two objects, they maintain their state. They maintain their state of rest or state of uniform motion. So now let us look at the example. First example we're going to look is related to state of uniform motion. There is no atmosphere in the outer space, as you know. Earth has an atmosphere, but the outer space doesn't has an atmosphere. It means that there is complete vacuum and there is no frictional force acting on any object in the outer space. So if we take the example of satellite that orbits the Earth, it is in the state of uniform motion. It remains in this state of uniform motion until any other external force acts on it. Uniform motion means that any object which travels uh, equal distances in equal intervals of time. Now let us look at the example of state of rest. So anything kept on table, any object kept on a table, it is at the state of rest. It means that there is no acceleration acting on that object. It remains at this state of rest until any external force acts on it. So, Newton's first law can be also described as law of inertia. Now, I want you to tell another thing. I want you to tell another thing that if you want a separate video on law of inertia in which I'm going to explain law of inertia in detailed manner, please demand in the comment box. I will surely make a video. Newton's first law is also related to law of inertia. And what law of inertia states tendency of any object to maintain its state of uniform motion or rest. Inertia cannot only be described as the tendency of any object to maintain its state of uniform motion or rest. There are other states of motion also. There is also the tendency of object to maintain that state. So, if you want a detailed video on law of inertia, you can demand in the comment box. Now, this is all about Newton's first law. Now we are going to study about Newton's second law. It is very important because more than 76% of the questions in competitive exams like NSTSE, SOF, NSO are based on Newton's second law. So let us look at what Newton's second law is. So Newton's second law also gives us a formula through which we can solve many mathematical problems. I'm going to give you an example of a mathematical problem, but it is going to be at the most basic level. Let us look at Newton's second law. There are three terms you need to understand in Newton's second law. That is a force, and in this case, the force is again the net external force. Force, acceleration, and mass. Now let us look at the Newton's second law. What Newton's second law states. amount of net external force acting on a body is directly proportional. What directly proportional means is that if the force is doubled, then the acceleration on any object is also doubled. Now, if you don't know what acceleration means, you are not really fit to watch this video. The amount of net external force acting on the body is directly proportional to the acceleration. If there's an if here, if the mass is constant. So the mass of any object remains constant always. Now let us look at the formula formed. The formula formed by Newton's second law is that the force equal the product of mass and acceleration. Now numericals would come from this. For example, a force is given, you impart a force on an object that is equal to 20 Newton. You don't know the mass of the object. You impart a force of 20 Newton and you know about it. Now you also observe that the acceleration that is created on the object due to your force is equal to 4 is equal to 4 is equal to 4. Okay, so ignore this, is equal to 4. Now the question might come that find the mass of the object on which you're imparting the force. This question based on Newton's second law is the most basic type of question. There are many other formula related to Newton impulse which are interrelated in many ways derived from the formula force equal mass into acceleration. If you want a video, please demand for it in the comment box. So we see that force equal mass into acceleration. We see this. Using this formula, how can we do this? Let's put the force and let's take the mass to be x equal mass. We don't know mass. X into acceleration, that is equal 4. Acceleration equal 4 here. So it can be also described as 4x equal 20, where x is the mass of object. So x equal 20 by 4. So 20 can be cancelled to 10 and 4 can be cancelled to 2 and 10 can be cancelled to 5 and we finally I'm sorry 20 can be cancelled to 2 and again 10 can be cancelled to again 1 and then we finally get the value as 1. X equal 5, I'm sorry, not 1, x equal 5. This is how you can use Newton's second law to solve most of the mathematical problems in competitive exams. So I'm going to erase all the ink. Let's look at next thing. This I've already explained, but there's one thing left to explain, and this is very important. And let's explain first this one. Force is directly proportional to acceleration. Force increases, acceleration also increases when the mass is constant. Force is directly proportional to mass. You also know that. And when the mass increases, the force that is required to maintain that acceleration also increases. Now, I told you a sentence just now. If you didn't understand the sentence, it is very tough for me to explain it again. You might rewind the video and look at the sentence again. Now, this thing, I have an example for acceleration is inversely proportional to mass. Inversely proportional to mass. And if you know what does this mean, it means proportional. Means proportional. Here it's directly proportional. Here it is inversely proportional because it is 1 by m. Acceleration is inversely proportional to mass. This thing means. Okay, now let us understand what it means. For a certain force, let us say the force is 20. When the acceleration is 5, the mass would be 4. But when the acceleration decreases, the mass increases. That is what is mean inversely proportional. When one thing increases, other thing decreases. When the acceleration becomes 4, the mass becomes 5. When the acceleration increases to 10, the mass of the object decreases to 2. Now let us take an example. You might read this example and understand. The same amount of force is applied on both a truck and a car. The acceleration produced by car is more than that of truck due to its mass. You might pause the video here and read this sentence and understand it properly. This will completely explain you this thing. And some who might have doubt will also get to know about Newton's second law. So you might also look at the PPT if you don't want to look at the video. So now let us learn about Newton's third law. Newton's third. I'm going to erase the ink. I'm sorry for that. Okay. So let's look at Newton's third law. It states, what does it state? It is quite simple and it is one of the most popular Newton's law. It states that every action has an equal and opposite reaction. What is an acceleration and what is a reaction? Action is when the force is acted by you, and reaction is the effect created by the force effect created on your hand when you act that force. Now there's a very interesting example for this. So you might read this sentence once. Pause the video and read this sentence. I'm sorry. We have to get a bracket here and close this brackets here. Okay, I'm gonna do this thing. Okay, now you play volleyball, right? You know what's volleyball. You hit the ball with your hand. Your hand exerts some force on the ball, due to which there's an acceleration on the ball. But when you hit the ball also tends to apply some force on your hand. But the acceleration is very less. Why? That is because the mass of your hand is larger. What you see here is that this example explains both Newton's first law and second law. I'm sorry, not first and second, second and third law. And now let us look at the last point. This is not a point, this is like a promotion: conservation of momentum. Conservation of momentum is a very important topic on which competitive examiners might, I'm sorry, not competitive examiners, any competitive questions might come related to this. And it is very important to know what conservation of momentum is. It is related to Newton's third law, so it is also good for us to keep it at the last. So if you demand for a video, please comment down. And that's all for today's video. I hope you learned all the three laws of Newton. I hope you liked the video. That's all for today's video.